Okay, welcome back. This is part 2 for section 4.2. So we're going to pick up where we left off. So now we're going to start talking about whether functions are even, odd, or neither. So we just finished up on increasing, decreasing, max and mins. So again, this is another area we can ask you questions about a function. So even, odd, or neither. So that depends on symmetry. Okay, so when you look at a graph, if you can see that it's symmetric to the y-axis, then that would be considered an even function. Okay, so there's a couple of ways, and we'll write them down here, that this talks about. Okay, so to be symmetric to the y-axis, that means the x values, whether they're positive or negative, would be the same values. The y values would equal each other. Okay, so if we let x be negative x or positive x, when we solve it, then y would be the same. That's what that says. Okay, and then you also have symmetry over the origin. That's a little bit harder to see. We'll talk about that. But if you have symmetry over the origin, then that's what we considered an odd function. And that means that if you put in a negative x for the x value in a function, then the y value also becomes negative. Okay, so that's what that means. All right, so those are our two things that we're going to be looking at. Y-axis symmetry means even. Origin symmetry would mean odd. And if it's anything else, then it would be neither of those. Okay? All right, so here's the algebra definition that we just did up there. So even would mean that f of negative x equals the original y value, which is f of x. And this is y-axis symmetry. Okay? All right, to be an odd function, f of negative x would be the opposite of y, which is negative f of x, and that would be origin symmetry. Okay? So notice there is no x-axis symmetry. I mean, you can have it, but not on here. Okay? All right, so first thing it's going to ask is just picking out from an equation. Most of you guys could, from a graph. Most of you guys can do this fine. So if you look at a function, you can see whether or not it's symmetric over the y-axis, whether it's symmetric over the origin, or neither. All right, so if I'm looking at this, I'm just going to do the even one first. So here's the y-axis. Okay. So if you would take your paper and fold it on that line, these two lines are symmetric, right? They would land on one another. That's what it means to be symmetric over the y-axis. So this is your even function, and it says explain in your own words why. And you would just say something about that it's symmetric to the y-axis. Okay? That's how I know by looking at a graph. So that's even. Odd, symmetric over the origin. Okay? So to be symmetric over the origin, any point here has to reflect over kind of diagonal from it. Any point here would end up here. Okay? An easy way to tell if something is odd, if you flip your paper upside down, so you guys are looking at your notes, and I take my paper and I turn it upside down, this looks exactly like it did right side up. That's how you know it's an odd function. This one obviously doesn't look the same, nor does that, but that's how you can tell. It's always a quick way to tell is turn your calculator upside down if you're graphing in C. So this is odd, okay, because it's symmetric on the origin. All right, and then this guy over here is neither. Okay, here's the y-axis, so both sides are not the same, and there's no symmetry over the origin, so this is neither. Okay, no symmetry. All right. Now, it says down here, the symmetry of equations. We say that an equation in x and y is symmetric with respect to the y-axis if you replace x with negative x and you get the same equation you started with. It's symmetric to the x-axis, which we're not doing because we'll talk about that in a minute. And then the origin, if you replace x with negative x and y with negative y, you get the same equation. Okay, so that's the jump over here. So if you are at, like, let's say this was the point 1, 2, then this would be the point -1, -2. okay? Here, when you're just symmetric to the y-axis, the only thing that's going to change is x. Y will stay the same value, okay? All right, so let's look at this next page is just some more kind of help for you guys, all the things that we just talked about. So this is just a good kind of definition page. All right, so even functions, again, they're symmetric to the y-axis. So if you look at this graph and fold your paper right there on that line, both sides look identical. So we've just talked about that you just replace the x with the negative, y stays the same. This is the function notation for that. And then this is what we're going to do for the algebra part, which is kind of important, okay? But just so you know. Odd functions, again, they reflect over the origin. So anything here would end up here, anything here would end up here. So both your x and y change, okay? And then again, this is the algebra for odd. Then you have the neither situation, okay? So none of those things are true. And then the reason I crossed out that middle one on the last page, because we don't do x-axis symmetry, because if you do x-axis symmetry, then you don't have a function, okay? You think about it. Here's your x-axis. So this graph would have x-axis symmetry, but it's not a function, right? It fails the vertical line test. So in this class, we don't deal with things that are not functions. So we would never give you, something to work out like this. Now we may give you a picture of it, but you would never have to work out anything else besides that, okay? So that's by looking at the graphs. Now, what if you're just given an equation and you're asked to tell whether it's even or odd? So there is a way to determine that without graphing, okay? Now you can use your calculator, I can't stop you from that, but I just want to show you, and that's why I circled these guys. I want to show you how to use these to find it if you don't want to graph it. So the directions actually got stuck down here, but the 4 problems we're going to do are on the next page. We're going to show, using algebra, whether the functions are even, odd, or neither. Okay, so that's on the next page. So let's look at number 7. All right, so there's 3 things we have to find. We have to find the original function, which you're given. We're going to do f of negative x, and then we're going to do negative f of x. Okay, and these are different, which some of you get a little confused on. So f of negative x, remember, means to replace any x in your problem with this number. So we're going to replace those with negative x, and then we're going to simplify it. This just means take the opposite of f of x. So you're going to just change the signs. Okay? All right, so let's put in negative x for our x's. So negative x cubed plus a negative x. And then you want to simplify that. That simplifies, any negative number cubed is negative, and plus a negative is just minus, okay? For your function to be even, this equation has to equal that equation. So they do not equal that, so they're not even. This is not an even function. Negative f of x says take the opposite of every term you see, which would be that. So notice that this equals that. So that's what it takes to be odd. Okay? That's what it said on those other pages. If you can show that f of negative x equals negative f of x, then you have an odd function. So that's your proof that you know it's odd. All right, let's look over here. So let's do g of negative x. So that means we're going to replace the x's with a negative x. So 1 over negative x squared plus 7 absolute value of negative x. And simplify. Well, any number squared is positive, so that goes back to x squared. And the absolute value of any number is positive, so that can go back to positive x. So now notice that you have those two equal. Okay? So I don't even have to find negative g of x. Okay? I can do it, but I don't really need to. This means change the signs, like that. Okay? But what's important is that g of x equals g of negative x. That means you have an even function. Okay? That's how you prove it if you're asked to show algebra. So again, to be odd, f of negative x has to equal negative f of x, and to be even, g of negative x or f of negative x has to equal the original function. So when you're doing the 3, either the top 2 are going to be equal or the bottom 2 are equal. Okay? All right, let's look at number 9. Let's take h of negative x first. That's replacing all the x's with a negative x. Simplify that. So a negative number to an odd power stays negative. Negative 2x to the 5th. Negative there. And then minus a negative turns that to plus. So those are obviously not the same, so it's not even. And the last one is the easy one. Just change all the signs. And now we have these two equal again. So because h of negative x equals negative h of x, then we know we have an odd function. All right, the last one. Here's g of x. So we're going to find g of negative x. Substitute in negative x everywhere you see an x. And simplify. So negative x squared is positive. And 4 times negative x is going to give you minus 4x. Not the same as that, so this is not even. Now we're going to do negative g of x, which means change all the signs. And notice these are also not the same. They have to be exactly the same. So none of these are equal. So this would be a neither problem. It's neither odd or even because neither one of those things worked out. Okay? All right, so that's how you do odd and even on paper, and then obviously you can graph it and look at the symmetry if you want to, if you're given a graph. All right, so here's a good problem that kind of goes over everything that we've been looking at today. All right, so let's answer these questions about our function. So part A, using this graph, what is the y-intercept? So your y-intercept is down here, so that would be at -2. Where are the x-intercepts? Or what are the x-intercepts? So we have 1, 2, 3, 4, we have 5. Okay, so here's 1 at -6. Here's 1 at -2. +2, +6, and 10. Right? Those are all our x-intercepts. Determine the domain and the range. Okay, so the domain, my smallest x is right here at -7, and my largest x is up here at 11. Not using -7, but I am using 11. So that would be the domain. Your range values, the smallest y is at -5, and it looks like the highest y value is 4, which you're using both of those. So from -5 to 4. Okay, increasing. So remember, x values. So we're going to increase, and all of these are parentheses. So don't have to worry about whether it's the solid or not. These are all parentheses here. So we're increasing from here to here. So that would be from -7 to -4. I'm also increasing from here to here, so 0 to 4. And I'm also increasing from here to here, so 8 to 11. Okay, decreasing in the other areas, so from here to here, -4 to 0. And here to here, which would be 4 to 8. Okay, so there's the parts of the graph that are decreasing. All right, for what values of x does f obtain a local max, and what are the local max? Okay, so remember, this is where and this is what. So where are our local maxes? So here would be 1 at -4. And then we also have a max here at +4. Remember, that is not a max because I don't know what's going on over here. Maxes have to change from increasing to decreasing. Okay, I have to see a change around it. All right, and what are the max? Be +4 and +2. Okay, All right, then we're going to do the same thing for the mins. Where are our minimums? Here's a min at x equals 0, and here's a min at x equals 8. Remember, that is not a min because I don't have a change from decreasing to increasing. I got to see that. All right, and then what are the min? So this min is -2, and that min is -5. All right, is the function even, odd, or neither? Okay. So looking at that, it's not symmetric to the y-axis. It's not symmetric to the origin. Okay, nothing looks the same, so this is neither. Now, this is a good question because remember what this says. For what values of x is f of x equal to 4? So remember, this is the y value, okay? X always goes in here. The number on this side is your y. So you're looking for the x values when y is 4. All right, well, y is 4 right here, and y is 4 right there. It's the only two places. So your answers would be at -4 and 11. Okay? So this is a good problem because if I asked you this, oops, if I asked you this, that's where is x equal to 4? You would find me, you're going to find me the y values, okay? But this is giving you the y value, x is what's missing. So pay attention to how the question is asked of you, okay? So be careful with that. All right. Last page, we're going to do average rate of change. So this is slope, just a real life situation on the words. So here's just the math behind it. So in a lot of situations in different aspects of life, we're comparing things that happen over a certain amount of time or over a certain interval. So what we do is, even though we might not have a straight line in our data, whatever we're looking at, we can connect 2 points. Any 2 points we can connect by a straight line. And so because it's not the exact curve, that's where it gets its name of an average rate of change. Okay? Because the change from here to here is not going to be consistent, right? Because it's a curve. But if I look at this line, I can give you an approximation. Okay, so that's what we're going to do here. And this right here is just the formula for slope. So remember, f of x2 is the same thing as y2, and f of x1, same thing as y1. So hopefully you guys remember that slope formula. Okay, so that's all we're doing to find the average rate of change. So you're going to need your x and your y values to do this. All right, so find the average rate of change for this function. So here's the graph of that function, x cubed minus 8, from x equals -1 to x equals 3. All right, so if x equals -1, I got to find y. Okay, so I'm going to find f of -1. So I'm going to put in -1 here and work this out. So -1 cubed minus 8 equals -1 minus 8, which equals -9. Okay, so I'm going to put this ordered pair here. Here's the point. There's -1, and let's call that -9 down here. Right? So there's that point. -1, -9. All right, now if x is 3, find y again. So that would be f of 3. Okay. So we're going to plug 3 in here. So 3 cubed minus 8. 3 cubed is 27. 27 minus 8 is 19. So now I'm going to come over here. Let's call this 3. And way up here will be 19. So 319. All right, so we want the average rate of change between these 2 points. So it's not a straight line at all, but what we're going to do is connect these 2 points like this. And then we're just going to find the rate of change for the slope. We're going to find the slope, which is, how much it changes, right? Rise over run. All right, so now we have our 2 ordered pairs, -1, -9, and 3, 19. Okay. So to find the average rate of change, we're going to just do y2 minus y1 over x2 minus x1. So we've got 19 minus negative 9, watch your signs, and then 3 minus negative 1. So that's 19 plus 9, which is 28. 3 plus 1, which is 4. And 28 divided by 4 is 7. So that would be the rate of change, average rate of change. Okay. All right, last problem. According to the U.S. National Center for Environmental Information database, the average temperature for Charlotte, North Carolina is 56 degrees in January and 81 degrees in May. Find the average rate of change in temperature per month from January to May. All right, so remember, we're going to call January month 1 and May is month 5, right? So in January, the temperature was 56, and in May, the temperature was 81. So we're going to find the average rate of change. Okay? So same thing, y2 minus y1 over x2 minus x1. So we're going to do 81 minus 56 over 5 minus 1. Okay? So you just take, and it doesn't really matter the order. If you did 56 minus 81 over 1 minus 5, you're just going to end up with a negative number over a negative number. And so that's still going to give you the same result. Okay? All right, so 81 minus 56 is 25. And 5 minus 1 is 4. So that's fine. You can't reduce it. Okay, but since we're talking temperature, let's go ahead and do 25 divided by 4, which is 6.25. So that makes a little bit more sense. So we would say the temperature increases 6.25 degrees per month in Charlotte from January to May. Okay, I don't know what happens the rest of the time, but this is what this says. So we found the average rate of change per month in Charlotte. Okay, so that's what that will tell us. That's what the average rate of change does. All right, so that ends section 4.2. All right, so now you're done with all of your notes. Let me know if you have any questions, if something's not ringing a bell before you get going on the homework. So just keep working. We're getting close to your first test, so please be reviewing all of your materials and always email me if you have any questions, okay? All right, take care.